All right. Thank you all for joining. It's November 2nd. Wow. We have a few topics that we can go to. Peter made a short video. We were just talking about efficient search and about different kinds of models. Also, I have one paper that I'd like to share that's related to knowledge engineering and requirements. So does anyone have any other topics to add?
I was hoping for an update on the taxonomy work that Chris was interested in, but since he's not here, or I don't know if anybody knows any other updates. Yeah, if there are any updates on that project, that would be great.
Okay. Well, if someone's listening and they know, they can let us know.
Thank you.
Anything else? Okay. Do you want to start with a short video of systems, or would you like me to first just share this paper, then we can discuss it for a few minutes?
Yeah, no, share the paper and I'll try and line it up.
All right. All right. I'll put this, I'll put it in the chat. And I'll put it in the links here. Okay, so this was a collaboration with two of my primary colleagues, RJ and Scott, and our colleague Tom in DHS. And it's a 40-page paper, so obviously not going to go over it, but just to give the very high level, which can also be reached at p3if.com. There are all of these different requirements, engineerings, frameworks. So in different areas. So all from data and cyber to just enterprise engineering, there's all these different frameworks that sometimes in a totally structured way, other times in a totally ad hoc way, bring up like all these different considerations. And sometimes it's just like really unclear. Other times it's very minimal. Other times it has like these kind of like hyper-dimensional features. And so what we realized is that those different considerations that are variously like brought up and elaborated by these different frameworks, like all the terms and the categorizations, fall out into essentially three categories: properties, processes, perspectives, also corresponding to adjectives, verb activities, and perspectives from nouns, or nouns as concepts describing perspectives. So giving us a feeling that could potentially classify all of these different considerations, which we did. So then in this paper, there's a lot of background section, but it identifies the primary issue, which is that there are these like different lineages of requirements engineering frameworks. And then people are always doing like the update and the 2.0, and it just becomes more and more complicated. And then importantly, there becomes divergence between like documentation and like what's the official version. And then there's also unclear mappings between the kinds of diligences that are required, which is an ever-shifting landscape, and the implementations and the actual like ways that these requirements and auditing approaches like come into play. Like it's not even my world per se, but there's a lot of issues there. So first we did this large-scale literature meta-analysis to curate these frameworks, which is at the P3IF. Then made this phylogeny, which is mainly based upon literature associations and kind of like direct allusions. So there's some crossovers between the different groups as time goes forward, but also there are these kind of like distinct lineages. Then we show like some of those different families. Here's the P3, properties, processes, and perspectives. And having that kind of higher order classification approach to all these diverse considerations allows us to basically refactor any framework previously seen into a cube, or potentially other shapes. Like, it doesn't even have to be limited to this, but just we're just going with a cube. So here's two examples of kind of like constructing a P3IF cube based upon, like, here are two sets of perspectives and three processes stages for like an information pipeline, and then like two sets, you know, there could be user and creator perspectives or something like that, each with their own business operation, legal, technical, social. Here's another usage. Here the cells are colored. The darker shade is corresponding to more classical cyber data security. So that's data, business data integrity. Could be like a records. That's this darkest cell. Whereas business policy efficiency is very light, representing a closer association, not with data encryption or like network structures, which might be a consideration up here, but with cognitive security, like narrative or psychological elements. Again, not even to say this is like the only way to color it, of course, but just, and then also kind of, which we can revisit with generative AI and all of this. So here's a 5x5x5 cube. So one person might be able to receive a 125 sentence generated report with the prompt for each cell, generate a 1-sentence summary. Another person might be just in the technical data compliance cell, and then that could be like rendered in a shifting landscape in that person's language, in that person's context. So those are documentation books that would never be printed for like this language at this time in this, because by the time you print something, it's already going to be out of date. But then this gives a structure to potentially generative systems that can unpack. So that was that work. And the aim is to use it within and across organizations. So if one organization has like consideration ABC, another has BCD, and then they're dealing with like any number of this infinite intersecting sets of requirements that come into play for different kinds of data, all these different things, then those can be kind of articulated into their PPP and then interfaced more legibly and more systemically with whatever it needs to be. So that was kind of a long time coming ultimately, but now it's done.
Looks fascinating. I'll go be able to click on the link somewhere on the code, all right, and find it.
Yeah, here and I put it in the chat too.
Okay, so give me an example of how that would apply to our current work here at ISSS for either knowledge engineering and creating a framework that's appropriate for what we're trying to do, or the educational, creativity piece that we're doing on the other Thursday. Could you give me an example of how that we might sort of take a look at one of these, the intersect of the 3 points, maybe?
Yeah.
3 themes. What did you call them?
The 3 Ps, the processes.
Yeah.
Processes perspective. Well, let's
it's out of interest.
I'm just gonna screenshot this guy. So this is kind of like the build your own requirements engineering framework. Like,
Right.
whose perspectives do we want to have? What processes are entailed? And then what properties does the system, do we want to have in the system?
Right. So for ISSS, what would that be within the context of education, let's say? So it's a design aid, in a sense, isn't it?
Yeah, it's totally a design scaffold and aid that's oriented towards actually interfacing with arbitrary requirements.
Hmm.
But yeah, throw out someone can throw out some sections and we can just set up a few.
Gonna play with it.
So here's a question, maybe it's a perspective. I'm not sure, are you familiar with value sensitive design?
Not totally.
Okay. So it's a process of identifying requirements through the lens of norms and values. So that might be, it's a little more, it's maybe a little different kind of approach. I'm not sure. But it seems to me that, like perspectives, might relate to a variety of perspectives on what's normal in a given environment or a changing environment, or what is expected in terms of a future norm. And then that conversation, is inflected the lens of, whatever values may be expressed or wanting to be expressed through processes, and ending up with system properties that somehow reflect those norms and values. Does that make sense?
Yeah, I mean, it's quite an extensive description on Wikipedia.
Yeah.
I think that's exactly it. That the properties could be just like, again, adjectives or just like first pass people, things that people want to uphold, and then conversations about like whose perspectives are included or whose perspectives are we accounting for. It's not like a virtue or implicit question. It's as explicit as that group wants it to be. And it can be, and this can be as informal as just written down on paper as a draft, or it could be like arbitrarily compliant. And then it's like, once things are separated out into those types, but being unopinionated about, and that's where we saw like limitations and trade-offs. So someone would be like, okay, confidentiality, integrity, availability, classical understanding. And then someone's like, but what about this topic? And so people were just trying to, it would be like, well, I want like a pickup truck with like double wheels on the back. And then someone's like, remove the double wheels and make this engine this way. And they're kind of arguing about which car is like the right car. And then there's all these weird like under and overbuilt cars because there's no sweet spot. Either it's vague and general enough to just be kind of evocative and fit on a single slide, or when it actually becomes used as a real framework, it's like you need like a certificate to even understand like what it even is. And then it's, by that time, it's like way captured with consultants and proprietary education.
Right. So, yeah, how we would maybe reflect that back is those what you described as properties of availability, integrity, confidentiality. Those would be, might be considered as values. And the translation of those values into concrete systems would be reflected in what's called, what might be termed a norm. Here's the normal way of how we do this, right? And those norms, they can change. There's probably hundreds of different ways to implement those values, and those norms are sort of embodied in communities and community processes.
Yeah. And to provide actually a little technical level of detail there. So active inference or surprise minimization, surprise bounding is exactly sets up for the constraints and norms. So it's like, if there was if a property that we expected was violated, we should be surprised. If there was a process included, or if we forgot a relevant one, false positive, false negative processes, we'd be surprised. Oh, we expected to process tomatoes and make it into tomato sauce. What is happening here? And then the perspectives that we include and what those perspectives are, where they're from a cognitive perspective, that's who we expect to be there and what we expect their engagement to be. And then that can be that can be formalized and fuzzy, which is kind of that double tension, because it's like, well, learners have a broad range of backgrounds. So then there could be subtyping or whatever it happens to be. But then it's like, there's obviously a trap or a risk of like over formalizing a perspective, literally overfitting or underfitting. So that's why I think it's an iterative process, which is why it's important to focus on like the ability of this to be used clearly.
Right.
And now we're developing tools so that people could actually like list things out and have this render and so on and so on. But this is just kind of just sketching it out there and releasing it as Creative Commons, so that now this idea it can never be enclosed. So then somebody might be like, well, we have this, like, we have our proprietary processes, or we have some special, just like we have a special Linux distribution or something. Anyone can do that.
Very nice. From my work at a large university in the UK, which had a portfolio of hundreds of different applications and quite a few of these frameworks and other requirements coming in as well. Just having a list and a taxonomy, even the simple 3Ps one, is very helpful for search and discovery and comparison, and maybe synergies or clashes, if it ever gets to that point. So from my time there, probably about 6 years ago, I wasn't aware of anything like this in the field. So this is looking very good.
Thank you. Yeah, there's probably a lot to say on that, but just like it's profitable to overfit, I guess. And there's a lot of inertia too, apparently. Yeah, any other thoughts, or we can kind of move on? But I mean, we made it so that it could be like a touch point, and that as people understand this just once, that it can help structure the conversation. Tom? Or
Almost having audio problems again.
Well, interestingly, I think maybe you're trying to create a framework for discussing norms in this domain. Variety of norms. So you got
definitely, yeah.
Yeah, you got a variety of communities out there. And it might be interesting to sort of dig into that and try to understand what values are being expressed through these norms, and also how those translate into, say, system requirements.
Yes. And that's also kind of the inter framework, is like system science helps build the generalization, and that would be like a meta framework. Like we could use category theory to as a research project to generalize across these different frameworks, as potentially people even have. But abstracting is only going to move us into a more general analytical space. So then that was kind of like the key difference, was to take an orthogonal approach and just say, what would be the inter, if this person needs ABC and then new requirement, DEF appear, why can't you just compose those just like they actually are? And then it's like, well, why can't you? Because there's the communication and requirements engineering based upon what? Based upon these legacy families of frameworks.
Well, there's been some discussion about norms and values, and you've focused this particular paper and use on business and enterprise architecture frameworks of frames of ideas and concepts, but the same requirement is there for individuals with a myriad array of models and frameworks that they have to bring to bear on just everyday living and activities. There might be some abstraction and crossover to individuals for individuals as well in a different focus.
Yeah, that's a great point. The personal P3IF. Yeah, what do you do in the day? What do you expect the day to be like? And then are you only taking your own perspective? Which there could be multiple of those. And then are you taking other people's perspectives?
And each one of us has hundreds of models to bring to bear. Yeah.
Yeah. And then just the meta-analysis is the first step. Just bring them all in, separate all the pieces out, reclassify them. Like maybe we can bring it to the website, but the separation of all the attributes, so like several hundred attributes across these different frameworks, and then build your own. And then you could say, okay, on brush my teeth from the perspective of a dentist so that it's gentle, is this cell? And then now make me a 60-minute podcast with these two scientists talking about that to that point. Or just, or again, just get the quick summary over a huge amount, or just continue to generate material within one cell, but then know whether you're kind of doing a whole row or like a whole sheet, or whether you're in a cell. And like system science, I think overall, hopefully it's helpful even without these computer tools. These tools are going to really differentiate this from like the ones that are more general and allow for more expression versus the ones that are more constrained and relying on kind of like legacy inertia.
I think you used the word orthogonal, or variation of it, and I think that's one of the keys here. Is whenever we adopt any particular one viewpoint or framework, we need to think orthogonally as well, because other important frames which complete the set are orthogonal and not in view, and need to be brought back into view, and multiple viewpoints brought to bear at the same time. And this sort of like cube-like representation sort of re-emphasizes that frame set requirement.
Yeah. I mean, consider a set of sunglasses that can only see one polarization of light. Rotation into the orthogonal, or two viewpoints that cancel each other. Or I mean, can't see the same thing or see non-overlapping things. These are kind of like first principles or facts about the cognitive engineering environment, of which enterprise requirements engineering is one type of.
There's another aspect here, and that is, so this is all very theoretical. And, I think one of the questions I would maybe think about entertaining is mapping out application and use as sort of separate categories. So you've got the framework, and then this is sort of a singular representative of multiple frameworks, plural, and then characterizing within that various applications and various usages, and that in itself is sort of a learning process, and within that entire space is sort of maybe evolution of frameworks, and trying to understand like what are contributory factors to that evolution, right?
Yeah, 2 points to that. First, to Tom's emphasis on the separation between like the semantic kernel of the model and the visualization. Obviously, that is possible here. You have a 200 by 200 by 200 object, single source of truth. And then for this context, we just need this view for this person. So then subset, make the visualizations like, wow, this one's really useful, this template visualization. And then the evolution and development of framework, that's so a little bit about what we saw, but this is just tip of the iceberg, but kind of like a species tree. But then you could look in like an organization's own history and be like, remember in 2023 we had these 5 adjectives, and then somebody like then this perspective added these 2 more, and then this requirement imposed that we do this, and then this new process became possible. Like then you could understand all of that unfolding just as a matter of documentation. But then because it's more active documentation, that can actually be the reference. Well, be the reference like a code base.
Right, and the purpose being either understanding, the landscape, or making predictions within that.
Yeah, and describing things as they are. The factory's already there. What is happening? What are the outcomes? Properties could be average temperature, or minimum maximum temperature, or it could be comfortable temperature. So it could be defined or proxied, however, first descriptively, and then people can start with the adjacencies and the counterfactuals on what is empirical, instead of a different overlay. So like, that's the thing, is like when Peter said, how do we approach this project? I mean, imagine if we even had this all at our fingertips, but usually people are going to have a much smaller set of even frameworks. How do we even know which one to choose? And then any given one is going to have things that we don't need and things that we missed and all of this.
Yeah, so yeah, that might be useful in trying to understand what goes wrong.
Yeah, or in the context of insurance or different kinds of information risk, you just say empirically it's the case that 7 out of this many did this with this property. And then if this process or perspective or property or combination is like that, then you get this much off your insurance, or then you have access, or then we require you to do this. If everybody has a 2-factor key, then this. But then that's on that was what was represented by the more cyber component, and then the real open space is, even though that's a changing landscape too, but the real open space is these conversations. I mean, from the perspective of a learner or ISSS member, or whatever, how the properties, which could be in and are in public documents, are understood. It's basically the conversation that people have like all the time.
Right. Now, what if you could use synthesized discourses to better understand the empirical discourses? Does that make sense?
Empirical one being like the one that people say.
Right. You were talking about, the descriptive aspect, right? And it seems conceivable with the emerging modeling paradigms, you could begin to create synthetic discourses, that kind of mimic empirical discourses. And through that kind of process, perhaps better understand the empirical discourses, where kind of you're discovering divergences from a predicted outcome. Does that make sense?
Yeah. Yeah. And this is more understood in the mechanical industrial and computational industrial settings, like if a network disruption were occurring. But in the purely cognitive space, semantic, narrative, communicative, that is the space that is left open by that. Yeah, I agree, Rob. Thank you for this fun discussion. Let us look at Peter's short video.
Where is that?
I don't know.
Hold on. I think that's it.
Okay, how
Yeah.
did you generate it?
No, you're not seeing that right now. Hold on.
We see just the browser window.
Do you see a browser window with a video in the
Yeah.
middle?
Yep.
Okay. So I went to well, it's called CapCut, CAPCUT.com, and I just said produce an introductory video to system sciences. And I did that at the beginning of this meeting, and it took 30 seconds to write the script. No, it didn't. It took 5 seconds to write the script. And then I said, create a video. And that was it. I haven't looked at this. I haven't read the script. This is the worldwide, first showing of this video that I have got no clue what it's going to say. So you're going to see it with me.
Hello everyone. Today I want to talk to you about system sciences and how they can help us solve some of the complex challenges facing our world today. So, what are system sciences? System sciences are a diverse range of academic disciplines and applied fields that focus on understanding and leveraging the behavior of complex systems. They aim to identify the key components, relationships, and interactions that make up a system, and to use that knowledge to predict and control its behavior. Applications of system sciences can be found in almost every aspect of our lives, from transportation and healthcare to climate change and artificial intelligence. So, how can system sciences help us create a better world? By understanding the complex interactions and feedback loops that govern the behavior of systems, we can gain insights into how to design and implement effective solutions for some of the world's most pressing challenges. For example, in the field of healthcare, system sciences can help us develop more effective treatment plans for diseases such as cancer. By analyzing the complex interactions between different cells and molecules in the body. In the field of transportation, system sciences can help us create more efficient and sustainable systems. By analyzing the interactions between vehicles, infrastructure, and the environment. In the field of climate change, system sciences can help us develop more effective strategies for reducing our carbon footprint. By analyzing the interactions between different sectors of the economy and different regions of the world. In conclusion, system sciences offer a powerful tool for understanding and addressing the complex challenges facing our world today. By leveraging the knowledge and expertise of scientists, engineers, and other experts, we can create a better world for all of us. Thank you for listening.
Aye.
Well, that wasn't bad as far as promoting system sciences for usage. It didn't say anything about what system sciences are.
I think I might have pushed the button that said promotional video, actually. That was a
Okay.
choice.
Wow.
But I mean,
Well-
that was literally, 2-3 clicks of a button. I mean, it was like introduce system sciences, write the scripts, then create the video, and then use a male or British voice. I could choose an American male, American female. But I mean, there's some licenses to, but it's just fascinating. You can do that now in seconds, right? With images.
Yeah. This is a great, I think, point to close and pick up and let us digest the rapidity and the profundity of the video.
One quick question: Do you have access to that video? Or
Yeah, I can edit it. I can edit the script. We can edit the script and rerun it. We could do anything. We can do anything. Yeah.
Oh, okay.
I could invite you all to participate in it as well. I could send. You could become collective editors of the whole thing.
That
can make a
kind of
YouTube
veers
channel.
into what I was talking about with synthetic discourses.
Yeah, in a way, that is a synthetic discourse.
Yeah.
Yeah. And so then, I mean, this is what's so interesting to me about this is that, the voice didn't sound particularly real, but it did sound authoritative because it was a British male, I guess. But he said kind of funny.
So
Yeah.
some variations on that might include, different kinds of audiences, like direct this to
Yeah.
school age children, or direct this to PhDs in biological science. or
Yeah, I
whatever.
had more words to write in there. I just said that one sentence. I could have said make it appropriate for K through, for students in middle school or something, and see what comes up.
Let's
But it's a
and-
particularly pragmatic possibility that if one wants to actually be doing something as a group, we could be editing the script and then pushing the button again, changing the images and editing anything that we want.
Yep. Let's return to it next week, but we can
Okay.
copy some of our notes and have like short media
Yep.
production within a meeting. So it's
Okay.
epic. All right.
Thanks.
Farewell.
See ya.
See y'all.